Okay, so in this video, let us continue our discussion on the land resources. Now, we live on land and we perform our activities, economic activities on the land, and we use it in different ways. So, land can be considered as a natural resource of utmost importance. It supports natural vegetation, wildlife, human life, economic activities, transport, and communication systems. However, land is not infinite. Excuse me. Land is an asset of a finite magnitude. Therefore, it is important to use the available land for various purposes with careful planning. Now, India has land under a variety of relief features, namely mountains, plateaus, plains, and islands. About 43% of the land area is plain, which provides facilities for agriculture and industry. Mountains account for about 30% of the total surface area of the country and ensure perennial flow of some rivers, provide facilities for tourism and ecological aspects. And about 27% of the area of the country is the plateau region. It possesses rich reserves of minerals, fossil fuels, and forests. So you can see 43% is plain, you have 30% is mountains, and about 20%, 27% is the plateaus. Now let us look at how land is utilized. So land resources are used for the following purposes. Of course, for forests, land that is not available for cultivation includes barren and wasteland where nothing can grow or it's just waste. Also land put to non-agriculture uses like buildings, roads, factories, and so on. And then it also includes other uncultivated land, which excludes the fallow land. So it includes lands like permanent pastures and grazing land for cattle and so on. Land which is under miscellaneous tree crops and groves, which are not included in the net zone area. And then cultivable wasteland, which is left uncultivated for more than 5 agriculture years. Then you have a category called fallow lands. So current fallow means left without cultivation for one or less than one agriculture year. That is what you mean by the fallow land. And then other than the current fallow, which means it is left uncultivated for past 1 to 5 agricultural years. And the net sown area of the physical extent of the land on which crops are sown, harvested, is known as net sown area. So area sown more than once in an agricultural year plus the net sown area is known as the gross cropped area. So this is a key thing. So area sown more than once in an agriculture year plus net sown area is known as the gross cropped area. So keep this in mind. Now let us look at the land use pattern in India. The use of land is determined both by physical factors such as the topography, climate, soil types, as well as human factors such as population, density, technological capability, and the culture and traditions. So two things: physical factors and the human factors. That's what governs the use of land. Now here is a graph which kind of is given by Directorate of Economics and Statistics, Ministry of Agriculture in 2017. And what it really shows is all these different categories of land use as forest, barren and unculturable wasteland, area under non-agricultural uses, permanent pasture, and area under misc, how this has changed from 1960-61 to 2014 to 15. So quite a few decades. Okay, now let us look at some of the analysis of these two graphs as described in the paragraphs below. So the total geographical area of India is 3.28 million square kilometer. However, the land use data that we have is available only for 93% of the total geographical area because land use reporting for most of the northeast states except Assam has not yet been done fully. Furthermore, there are some areas of Jammu and Kashmir which have been occupied by Pakistan and China have also not been surveyed. So the land under permanent pasture has decreased. How are we able to feed our huge cattle on this pasture land and what are the consequences of it? So if you look at land under permanent pasture, so let's look at it. Where do you think you can see this purple thing over here? permanent pasture and grazing land is 4.71%. And here you can see that it is reduced to 3.3%, right? So that is quite a significant difference, more than a percent, right? Now that is huge when you look at the millions of square kilometer. So what are the consequences of this, right? So most of the other than the current fallow lands are either of poor quality, or the cost of cultivation of such lands is very high, which makes it economically less feasible or just infeasible. Hence, these lands are cultivated once or twice in about 2 to 3 years. And if these are included in the net sown area, then the percentage of net sown area in India comes to about 54% of the total reporting area. So, roughly, we can only have 54% of the land of the 3.28 million square kilometers as the net sown area. So the pattern of the net sown area varies greatly from one state to other. It's over 80% of the total area in Punjab and Haryana, and less than 10% in Arunachal Pradesh, Mizoram, Manipur, and Andaman Nicobar Islands. Again, keep in mind that the way we utilize land, it depends on human factors as well as the geographical factors. Now, forest area in country is far lower than the desired 33% of the geographical area. So this is very interesting. If you look at the forest here, which is the blue, it's 18%, while it has increased to 23.3% from 1960 to 61. It is still less than the desired 33%. So we expect that 1/3 of the land should be the forests. So it was considered essential for the maintenance of ecological balance. That's why we need 1/3 of the land. So the livelihood of millions of people who live on the fringes of this forest depends on it. A part of the land is termed as wasteland and land put to other non-agricultural uses. Wasteland includes rocky, arid, and desert areas, and land put to other non agricultural uses includes settlements, roads, railways, industries, and so on. Continuous use of land over a long period of time without taking appropriate measures to conserve and manage it has resulted in land degradation. So, this is a concept, land degrades. Now, this degradation has serious repercussions on society and the environment. So now let us explore this concept of land degradation and what are some of the conservation measures that can be put in. Now we have shared our land with our past generations, and we will have to do so with the future generations too. So again, we have to remember that we are just the guests on this planet Earth, and whatever we use, we have a responsibility of using it properly, so that not only do we live a good life, but we also live the natural resources for the future generations to come. Now 95% of our basic needs for food, shelter, or clothing are obtained from land. It is so important. That is why normally when people refer to as earth, they call it mother earth. Human activities have not only brought about degradation of land, but have also aggravated the pace of natural forces to cause damage to the land. Now, some human activities such as deforestation, overgrazing, mining, and quarrying too have contributed significantly to the land degradation. So, these are the activities which cause land degradation. Okay, now let's look at mining. Mining sites are abandoned after excavation work is complete, leaving deep scars and traces of overburdening. In states like Jharkhand, Chhattisgarh, Madhya Pradesh, and Odisha, deforestation due to mining have caused severe land degradation. Okay. In the states like Gujarat, Rajasthan, Madhya Pradesh, and Maharashtra, overgrazing is one of the main reasons for land degradation. So you can see how the human factors, okay, and the topographical features leads to certain overuse, certain ways in which we overuse the land. Okay, in the states of Punjab, Haryana, Western Uttar Pradesh, over irrigation is responsible for land degradation due to waterlogging and leading to increase in salinity and alkalinity of the soil. The mineral processing like grinding of the limestone for cement industry and calcite and soapstone for ceramic industry generate huge quantity of dust in the atmosphere. It retards the process of infiltration of water into the soil after it settles down on the land. In recent years, industrial effluents as waste have become a major source of land and water pollution in many parts of the country. There are many ways to solve the problems of land degradation. Afforestation, which means planting forest, and proper management of grazing can help to some extent. So, this is one, afforestation. Second one is management of grazing. The third one is planting of shelter belts of plants, control on overgrazing, stabilization of sand dunes by growing thorny bushes are some of the methods to check the land degradation in arid areas. Now, proper management of wastelands is also important, so that you can also control the mining activities, proper discharge and disposal of industrial effluents and wastes after treatment can reduce land and water degradation in industrial and suburban areas. Now, let us look at soil as a resource, right? Let's try to understand why soil is such an important thing for us humans as a resource. So, soil can be considered as the most important renewable natural resource. It is the medium of plant growth and supports different types of living organisms on the earth. The soil is a living system. This is a key thing to keep in mind. It takes millions of years to form soil up to a few centimeter in depth. Okay, relief, parent rock or bedrock, climate, vegetation, and other forms of life and time are important factors in the formation of soil. Various forces of nature, such as change in temperature, actions of running water, wind and glaciers, activities and decomposers, etc., contribute to the formation of the soil. Chemical and organic changes which take place in the soil are equally important. So, soil consists of organic, that is humus, and inorganic materials. Now, on the basis of the factors responsible for soil formation, color, thickness, texture, age, chemical and physical properties, the soils of India are classified into different types. Now, this is just this is an important diagram which shows you the soil profile. So you can see that the top soil is a very small layer, right? This is where most of the plants and all of that grow. Then you have subsoil, the second layer, which mostly consists of weathered rocks, sand and silt clay. Then you have substratum, weathered parent rock material, and then you have a parent bedrock on which this kind of the other layers are resting upon. So now let's look at the classification of soils. Now, as India has varied relief features, landforms, climatic realms, and vegetation types. Now, these have contributed to the developments of different soil profiles or different types of soils. So let's first start with alluvial soils. So you can see the picture here, which shows what alluvial soils look like. Now, this is the most widely spread and important soil. In fact, the entire northern plains are made of alluvial soil. These have been deposited by three important Himalayan river systems, the Indus, the Ganga, and the Brahmaputra. So you can think that alluvial soil kind of gets deposited by the rivers. These soils also extend in Rajasthan and Gujarat through a narrow corridor. Alluvial soil is also found in the eastern coastal plains, particularly in the deltas of the Mahanadi, the Godavari, the Krishna, and the Kaveri rivers. The alluvial soil consists of various proportions of sand, silt, and clay. This is a key thing to know. As we move inlands towards the river valleys, soil particles appear somewhat bigger in size. In the upper reaches of the river valley, that is near the place of the break of the slope, the soils are coarse. Such soils are more common in Piedmont plains such as Duars, the Chos, and the Terai. Now, apart from the size of their grains or components, soils are also described on the basis of their age. According to their age, alluvial soils can be further classified as old alluvial, which is called Bangar, and new alluvial, called Khadar. The Bangar soil has higher concentration of conquered modules than the Khadar. It has more fine particles and is more fertile than the Bangar. So again, for you to remember, old alluvial soil is known as Bangar and new alluvial is known as Khadar. And Bangar soil, because it is old, it has higher concentration of conquer nodules than the Khadar. Now, alluvial soils as a whole are very fertile. That's the main thing. That's why a lot of farming activity happens in the northern plains. Mostly these soils contain adequate proportion of potash, phosphoric acid, and lime, which are ideal for the growth of sugarcane, paddy, wheat, and other cereal and pulse crops. Due to its high fertility, regions of alluvial soils are intensively cultivated and densely populated. Soils in the drier areas are more alkaline and can be productive after proper treatment and irrigation. Now let us look at black soils. You can see the picture of a black soil. How does it look like? So these soils naturally, as the name is says, it's black in color, and they are also known as Rager soils. Black soil is ideal for growing cotton and is also known as black cotton soil. So you can remember black cotton soil. It is believed that climatic action along with the parent rock material are the important factors for the formation of black soil. This type of soil is typical in the Deccan Trap basalt region spread over the northwest Deccan Plateau and is made up of the lava flows. They cover the plateaus of Maharashtra, Saurashtra, Malwa, Madhya Pradesh, and Chhattisgarh and extend to the southeast direction along the Godavari and the Krishna valleys. The black soils are made up of extremely fine, that is, clayey material. They are well known for their capacity to hold moisture. In addition, they are rich in soil nutrients such as calcium carbonate, magnesium, potash, and lime. These soils are generally poor in phosphoric contents. They develop deep cracks during the hot weather, which is why you saw that typical picture of the black soil with cracks, which helps in the proper aeration of the soil. Now, these soils are sticky when wet and difficult to work on unless tilled immediately after the first shower or during the pre monsoon period. Now let us look at the red and the yellow soils. So red soil develops on crystalline igneous rocks in the areas of low rainfall in the eastern and southern part of Deccan Plateau. Yellow and red soils are also found in parts of Odisha, Chhattisgarh, southern parts of Middle Ganga Plain and along the Piedmont zone of the Western Ghats. These soils develop a reddish color due to the diffusion of iron in the crystalline and the metamorphic rocks. It looks yellow when it occurs in a hydrated form. Hydrated is when it has water in it. Now let's look at laterite soil. So this is the picture of the laterite soil. You can see it's a very unique yellowish kind of thing. So laterite has been derived from the word later, which means brick. The laterite soil develops under tropical and subtropical climate with alternate wet and dry season. This soil is the result of intense leaching due to heavy rain. Lateritic soils are mostly deep to very deep, acidic, which pH of less than 6, and generally deficient in plant nutrients and occur mostly in southern states. Western Ghats region of Maharashtra, Odisha, some parts of West Bengal and northeast regions. Where these soils support deciduous and evergreen forests, it is humus rich, but under sparse vegetation and in semi-arid environment, it is generally humus poor. They are prone to erosion and degradation due to their position on the landscape. After adopting appropriate soil conservation techniques, particularly in the hilly areas of Karnataka, Kerala, and Tamil Nadu, this soil is very useful for growing tea and coffee. Red laterite soils in Tamil Nadu, Andhra Pradesh, and Kerala are more suitable for crops like cashew nut. Now let us look at arid soils. So arid soils range from red to brown in color. You can see the reddish to brownish color over here. In some areas, the salt content is very high, and the common salt is obtained by evaporating the water. Due to the dry climate, high temperature, evaporation is faster, and the soil lacks humus and moisture. The lower horizons of the soil are occupied by the conker because of the increasing calcium content downwards. The conker layer formations in the bottom horizons restrict the infiltration of water. After proper irrigation, these soils become cultivable and has been the case in western Rajasthan. And then let us look at the forest soils. So these soils are found in the hilly and mountainous areas where sufficient rainforests are available. The soil's texture varies according to the mountain environment where they are formed. They are loamy and silty in valley sides and coarse grained in the upper slopes. In the snow covered areas of the Himalayas, these soils experience denudation and are acidic with low humus content. These soils are found in the lower parts of the valleys, particularly on the river terraces, and the alluvial fans are fertile. So this is a good picture here which gives you the whole idea of the different soil types. So as you can see that the most northern part of India here, this is this, and combined with some other regions, northeastern, that's mostly forest and mountainous soils. Then you can see where do you find the alluvial soils, which is part of Gujarat, but majority of the northern side of India and some parts in the northeastern states is alluvial soil. Then you can see how the red and the yellow soil is mostly towards the sort of west east kind of part, not west but yeah, this side of the India, and also more or less towards the south, with some kind of regions here where you find this. Black soil is found in this region, right, this other part of the land. Then you can see laterite soils is not that much. There are only less places where you can find, mostly coastal regions. And then you have, of course, the arid land. So you can see like big parts of the Rajasthan, there it's arid land because it's kind of mostly a deserty region, and so on. So yeah, I think it is a good idea for you to just understand where each kind of soil is found. This is a good way. If you can remember this picture and see where its soils are, then it makes it easy for you to understand the kind of soils that you find and where do you find them. Okay, so now let us look at the soil erosion and the soil conservation. So the denudation of the soil cover and subsequent washing down is described as soil erosion. The process of soil formation and erosion go on simultaneously, and generally there is a balance between the two. Sometimes this balance is disturbed due to human activities like deforestation, overgrazing, construction and mining, etc. While natural forces like wind, glacier and water lead to soil erosion. The running water cuts through the clayey soils and make deep channels as gullies. The land becomes unfit for cultivation and is known as a bad land. In the Chambal Basin, such lands are called ravines. Some water flows as a sheet over large areas down a slope. In such cases, the topsoil is washed away. This is known as sheet erosion. Wind blows loose soil off flat sloping land, known as wind erosion. Soil erosion is also caused due to defective methods of farming. Plowing in a wrong way, that is up and down the slope, form channels for the quick flow of water, leading to soil erosion. Plowing along the contour lines can decelerate the flow of water down the slopes. This is called contour plowing. Steps can be cut out on the slopes, making terraces. Terrace cultivation restricts erosion. So this is why you will find that there are many regions in India where slopy regions where you have terrace cultivation. Western and central Himalayas have well developed terrace farming. Large fields can be divided into strips. Strips of grass are left to grow between the crops. This breaks up the force of the wind. This method is known as strip cropping. Planting lines of trees to create shelter also works in a similar way. Rows of such trees are called shelter belts. These shelter belts have contributed significantly to the stabilization of sand dunes and in stabilization of the desert in the western India. And that brings us to the conclusion of this chapter.